Welcome. We're going to now go into probability. And the most important thing about probability is we're going to assume that most every event has the same probability as any other event. So for what I mean by that is if I have three cards that I shuffle and randomize, there's just as much of a probability of picking out the one card as there is the two card, or as there is the three card. So the probabilities are going to be equal for each individual event. And what I mean by event is, again, drawing a 1 or drawing a 2 or drawing a 3. So there's three possible outcomes or events that could happen. Now, the way this is written, I want to emphasize what this means here. This P just stands for, they're asking for what's the probability. It's not a variable. It's not P times some prime number. It's just what's the probability of whatever they have written in here happening, whatever this event is. So for this particular problem, they're asking what is the probability that you draw a prime number? Well, there's only two prime numbers in here. By definition, 1 is not prime. So I want to emphasize that. A lot of students don't realize that. 1 is not prime, but 2 is prime and 3 is prime. So in other words, you have two cards out of 3 that you could possibly get that would be prime. And that's how you calculate theoretical probability. There's the total number possible of things that could happen, and then there's the total number of successful outcomes. So again, it's the number of successes divided by the total possible number of outcomes, all of the things that could possibly happen. And then we write it as a fraction. So in here, I just type in, there's a 2/3 chance I'm going to get either the 2 or the 3. Again, a spinner, if you'll notice, the areas of each pie section is the same. So again, theoretically, we're going to assume it's just as likely to land on a 5 as it is a 7 or as it is a 6. So then when we read the problem and it says, what is the probability that we get a factor of 35? Well, all we need to know is which one of these numbers are factors of 35. Well, I know 5 goes into 35, 7 goes into 35 because 5 times 7 is 35, but 35 is not divisible by 6 evenly. So 6 is not a factor. So we have one of these two chances out of a total of 3 chances. 2 of those pie sections work. The one doesn't, but it's 2 out of 3. Remember, it's always the number that work over the total. So this would be a fraction of 2/3. Again, a 6-sided dice. It's just as likely to land on the 1 as it is the 2 or the 4 or the 3 or the 5 or the 6. So what is the probability of even? Well, how many even numbers are on the 6-sided dice? There's a total of 6 sides we could get, and 3 of them are even. So 3 successes out of a total of 6, that reduces to a 1/2 chance. Or how do we convert 1/2 to a percentage? 1/2 is 0.5. And 0.5 is 50%. So hopefully you guys can convert your fractions into decimals and your decimals into percentages. If you need a review on that, please ask me in class and I will help you converting your fractions and your decimals to percentages. Again, what is the probability of landing on a heads? Well, there's either one side or the other. Where again, this is theoretically. We're going to assume that you cannot land on the edge and stand up like it's on rolling down the hill. It's going to either land on the one or land on the other, the heads or the tails. So that means there'd be a 1 out of 2 chance or a 50%. Again, nothing in here should be really that much more difficult than that. If you end up having any questions, please do let me know. Oh, one last thing, it is possible for it to be 100%. What is the probability that I land on a heads or a tail? Well, there's only the 2 chances. And by the way, what is 100% as a fraction? Well, it's 1/1, or as a decimal or a whole number, it's 1. So there will be times where you actually get a 1. I'll bet there are actually times where you get zero. There's no chance. We said, wonder if it said, what is the probability that the penny lands on the moon? No probability, because you can't throw that high. Anyway, so you get the idea. If you have questions, please bring them to class.